Tension. When a cord, rope, or chain pulls on an object, it is said to be under tension, and the force it exerts is called a tension force, F sub T. The tension force is the same throughout the cord, rope, or chain, when assumed to be massless. Any object that is hanging or suspended is considered to have tension acting upward. Any object that is pulled is considered to have tension acting on it. There's no special formula to find the tension force. Just use a free body diagram and net force equations, Newton's second law, to solve for the tension. A 150 kilogram load is suspended from a chain. What is the tension force supplied by the chain? Alright, seeing as though this load is stationary, it's definitely not accelerating, so A is going to be equal to 0. Forces are only in one dimension, so we'll do Newton's second law for the vertical dimension. Tension up is positive, minus mg down, which is negative, equals 0. Therefore, the tension equals the weight of the load. So 150 kilograms times little g gives us 1,470 newtons. A crane accelerates a 175 kilogram load upward at a constant rate of 1.2 meters per second squared. Find the tension force in the supporting cable. This time is different because we do have acceleration upwards, which means the upwards force must be greater than the downwards force, giving us a net force that is upwards, and therefore an acceleration that is upwards. So we'll start with Newton's second law. We have tension force upwards in the positive direction, so Ft is positive. In the negative direction, we have mg, so it gets a negative sign. In this problem, we do have acceleration, so we need to leave that term in. Now we're going to solve this for F sub t, therefore add mg to both sides. You can factor out that m if you want, or not. Plug your numbers in, and we get 1,925 newtons. Since the acceleration is in the same direction of the upward motion, the tension force is greater than the weight of the load. If you calculate the weight, you'll see that it's 1715 newtons. So yes, tension is greater than the weight. A crane is moving a 175 kilogram load upward, but is slowing down at a constant rate of negative 1.2 meters per second squared. Find the tension force in the supporting cable. In this case, the load is moving upwards, so its velocity is upwards. However, it's slowing down, which means its acceleration is downwards, negative. Nothing about a free body diagram will give you any information about an object's velocity. However, it will give you information about acceleration. So we have a tension force upwards, weight downwards. Since its acceleration is in the negative direction, the force of mg, gravity, will be greater than the tension force. Let's see how this works out algebraically. We start with Newton's second law. We have tension up minus weight down equals negative ma. So see how, because a is in the negative direction, we also have to make a negative over here. So then we solve for tension, we plug in our numbers, so we have 1.2 acceleration, but it is negative. So that's how that negative sign ends up here. Now, if you want to just make your acceleration negative up here, you could use, you wouldn't have to remember to put the negative sign out here. But at some point, you're going to have to make sure that acceleration gets a negative sign. Plug your numbers in, and we get 1505 newtons. Since the acceleration is opposite the upward motion, the tension force is less than the weight of the load. Remember, the load weighs 1715 newtons. Now the tension's only 1505.